Okay, so in this video, we're going to look at measuring distance. So on mine, it's on page 30 to 31. So it should be around there if yours just printed slightly different. Okay, so the first thing is, what is measurement? And we're going to talk a lot about measurement when we get to unit 3. But measurement is the size, length, or amount of something. Okay, so there's different types of measurements. We often do like area, volume, perimeter, length, weight. Those are all different types of measurements. So if we look at our packet, it's going to talk about right triangles. So right triangles are very useful. Do you know the length of the hypotenuse? We could cut off part of our graph paper and make a ruler to measure, but in this case, you have two options since you have a triangle on graph paper. And so there's two ways to measure distance. The first way is the Pythagorean theorem. And that only works again if we have a right triangle, but if we have any 2 points, we can always create a right triangle with them. And so for the Pythagorean theorem, it's the a squared plus b squared equals c squared. So the a and b are called the legs. You can switch those two measurements, it won't matter. But the c is always the hypotenuse, which is the longest side. And that's very important that you get c right, or else your answer will be incorrect. Okay, and then the second way is the distance formula. So this is the distance formula. It really comes from the Pythagorean theorem. It's just saying that A is the same as x2 minus x1, and B is the same as y2 minus y1, which is one way to find A and B. And then this is solved for C by taking the square root of both sides. So this is the distance formula. So we're going to use both of our options to determine the distance between the 2 points that make up the hypotenuse. So we're looking for the distance between B and C. And so the first way would be doing the Pythagorean theorem. So we find AB just by counting. So 1, 2, 3, 4, 5. So this side is 5, and we can call this side A. And then A to C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, and we can call this B. And then we're looking for this side, which is C, the hypotenuse. The hypotenuse is always the one that's across from the right angle, and it's always the longest side. So if I was going to do the Pythagorean theorem, I would do a squared plus b squared equals c squared. So we said a was 5, so 5 squared plus. We said b was 13, so we would do 13 squared equals c squared. So we're just taking these values and plugging into that formula. So 5 squared is 25. 13 squared is 169. If you add them, you get 194 equals c squared. And then here's where you will need a calculator for most of these. You're going to take the square root of both sides when you get there to get rid of the squared. Okay, and the square root of c squared is just c. And if you take the square root of 194, you'd have to use your calculator. You get like 13.928. Okay, so that's using the Pythagorean theorem. So the second way is using our distance formula. Okay, and so for the distance formula, we need the points of the endpoints of our line that we're finding. Again, we're finding the length of BC. So B is 1, 6, and C is 14, 1. And so those are my 2 points. Okay, so I have 1, 6, and 14, 1. And it really doesn't matter which one you put first, which one you second. But then I'm going to call my points X and Y. So this one I'm going to call my X1, Y1, just because this is the point I made first. And then this is X2, Y2. Okay, just remember every point is X comma Y. And then the subscripts have to match. And then we just plug it into this distance formula. So D equals, so X2, so we would do 14 minus X1, which is 1 squared, plus y2, which is 1 minus y1, which is 6 squared. And then we're going to take, again, we do order of operations. So we do parentheses first. So 14 minus 1 is 13. And 1 minus 6 is negative 5 squared. And then these numbers, other than the sign, should match up with what we got for our A and B. Because again, to find A and B, you are really just subtracting the endpoints of your segment. And then just be careful with the negatives. I just want to show, if you have a TI or any other calculator, it's really easy to make a mistake on these, and a lot of students do. So whenever you have a negative and you're squaring it, you have to put it in parentheses. Okay, if you just put -5 squared, it's going to give you a -25, and that should be a red flag, because you should know that when you square something, it's always positive, because you're multiplying it by itself, and a positive times a positive is always a negative times a negative is always a positive. So whenever you're squaring a negative number, you have to put the negative in parentheses and then square it, because if you don't, this does order of operations, which says, okay, I square first, and then this is really like a -1. I multiply by that -1, which is how I get -25. This, by putting parentheses, is saying, okay, this number is -5, and that's what I'm squaring. So I'm doing -5 times -5, which is +25. So anytime you have a negative, just like keep in mind, you should always be getting a positive. And if you don't, then you forgot the parentheses in your calculator. Okay, so again, this gives me 169 plus 25. This gives me the square root of 194, which is 13.928. Okay, so that's the two different ways to do the Pythagorean, or to find the distance between 2 points. Okay, so we're gonna look at just like a few other ones. So question 3 says, suppose that a cup on a miniature golf hole requires you to putt the ball 24 feet forward and then abruptly turn and putt 7 feet to the right. So we want to draw a picture of this. So I am starting, I guess, at the tee or somewhere, wherever my ball is, and I'm going to putt the ball 24 feet forward and then abruptly right. So let's say we're going to say forward is like here. So we're going 24 feet that way. And then wherever I stopped, and then abruptly turn right 7 feet. So it looked like this. And we're trying to find how far is the ball from the cup. So we're looking for this distance. And we know this is 24 and this is 7. See if you can solve using the Pythagorean theorem and the distance formula. Write your solutions. Well, your solutions will be similar. They will be slightly different in approach. Okay. So for Pythagorean theorem, we would just need the triangle, and we would do like a squared plus b squared equals c squared. Okay, now again, a and b are interchangeable. Usually we say a is the smallest, so I would do like 7 squared plus 24 squared equals c squared. Okay, we're trying to find this, the length of that hypotenuse, and then we get 49 plus 576 equals c squared. Okay, and that gives us 625 equals c squared. And if we take the square root of 625, that will give me that distance, and that is 25. Okay, so that's standard Pythagorean theorem. Now, if you wanted to do this in the distance formula, what you should do is you should make a graph. And what the easiest way, you can really do like anywhere, but what I would do to make your life easiest is just make the graph so that the origin is where those two sides come together. And then this point would be 0, 24. And this point would be 7, 0. And then when you're doing the distance formula, you would just use those points. So this would be like x1, y1, x2, y2. And then you would do x2. So 7 minus x1, which is 0. And then y2, which is 0 minus 24 squared. Okay. And again, you could set it up like, you could put these anywhere. Like you could start at 21, 25, and then you would just have to subtract 24 to get to your next point and go right 7. But it's much easier to just set it up with the origin where these two sides intersect. So then we get 7 squared plus -24 squared. Remember, that needs to be in parentheses, which again is 49 plus that 576. which gives me the square root of 625, which is just 25. Okay, so that's doing it using the distance formula. You don't have to do both ways on the homework or the exam. You can pick whichever way you're most comfortable. Most students prefer the Pythagorean theorem, which is fine. Okay, so question 4 is just one more kind of practice. So now use a strategy that you discovered to determine the distance of the hypotenuse below. You can really pick your method. So what I recommend is just like pausing, picking it, and then checking your answer with what I get. Okay, so hopefully you paused and came back. So I counted my two sides, A and B. If I was doing the Pythagorean theorem, I would do 6 squared plus 8 squared equals C squared, okay, which is 36 plus 64 equals C squared. That's 100 equals C squared. And then if we take the square root of 100, we get 10. Okay. If I wanted to do it the other way with the distance formula, this point is 1, 7. This point is 9, 1. This, let's say our x1, y1, this is x2, y2. Again, it doesn't matter which point you call x1 and which one, you'll get the same way. It's just when you subtract, you'll get opposite signs. But when you square it, then it doesn't matter. So here I would do 1 minus 9 for x2 minus x1 squared plus y2 minus y1 squared. So I get negative 8 squared plus 6 squared. Okay, and again, these numbers should match up. The signs might not match up, but they should match up with what we have here, which is 64 plus 36, and that's the square root of 100, which is also 10. Okay, so those are the packet problems on measuring distance and Pythagorean theorem.